Every comet expert agrees, 3I Atlas is behaving unlike anything we've ever studied. As this interstellar visitor speeds toward its close encounter with Mars and the Sun later this year, its behavior is defying all our expectations. It's developing a coma, its fuzzy atmosphere, rich in carbon dioxide, CO2. Far more CO2 than water vapor, a ratio almost never seen in comets. R-Sive plus 2 live. Science plus 2. It seems to be brightening more rapidly than prediction models would allow. R-Sive plus 1, its dust and gas emissions, spectral signatures, and polarimetric behavior are all unusual. Archive plus 2 astrobiology plus 2, but amid all this, something even more mysterious. Despite the worldwide buzz among amateur astronomers, major space telescopes and missions are not publicizing much new imaging or commentary since August. No big alerts, no dramatic press releases, which is odd, given how unusual this comet is. In this deep dive, we'll explore why 3I Atlas is acting so bizarrely, what scientists do know so far, and why there's a strange silence from the official sources. Part 1. A comet that's breaking the rules in. Mid-September 2025, 3I Atlas started to diverge from predicted behavior. Models and predictions, light curves, based on decades of comet studies give us expectations. How bright comets should get as they warm up, how gas and dust are released, how dust scatters light. But this comet hasn't followed that script. Predictions had 3I Atlas brightening steadily as it moved inward through the solar system. And for a while it did just that, Archive plus 2 R-Sive plus 2. But around early to mid-September, observers noticed brightness data points above the predicted curve. The light curve steepened. The comet seemed to accelerate its brightening. Archive plus 2 astrobiology plus 2. Some are arguing this is a genuine comet outburst. Others say it's possibly an aperture effect, i.e. differences in telescopes, detectors, etc., that make the comet appear brighter under certain observing conditions. Not because it actually is doing something extra. But even taking those observational uncertainties into account, the deviation seems significant. Archive Part 2. Chemistry, coma, and excess CO2 here is where the real strangeness begins. Some of the most recent observations show the James Webb Space Telescope, JWST, captured a coma dominated by CO2, with a CO2 to H2O ratio of about 8.0 plus 1.0. That is among the highest ever recorded in a comet. Ar-Sive plus 2 live science plus 2 other molecules are present. Carbon monoxide, CO, OCS, carbonyl sulfide, dust, and water ice. However, the water gas emission is much weaker than expected at this orbital distance. Archive plus 2 live science plus 2. The Swift Observatory detected OH emission, AT, typical proxy for water. At about 351 AU from the Sun, the water production rate was roughly 130 plus 0.27 171 35 plus 0.7 137 molecules per second on 40 kilogauss. That's more water than many comets produce at similar distances, but still small compared with the huge CO2 outgassing. R-Sive. In addition, observations show an extended coma of CO2, as measured by Spherex. The coma extends hundreds of thousands of kilometers. Spherex polarimetric measurements, which study how light polarizes when scattered, show 3I Atlas has a deep and narrow negative polarization branch, reaching about 2.7% at a small phase angle, Popshaber 7 degree, with an inversion angle around 17 degrees. This is unusual even among comets and asteroids, and says something odd about the mix of ice, dust, and how light is scattered in the coma. Archive Part 3. What we don't know and what we're questioning, given the data. Here are the major unknowns and possible explanations. Size of the solid nucleus. JWST. Hubble and ground-based telescopes give upper bounds. Hubble's imaging, July 21, 2025, constrains the nucleus to no larger than 5.6 kilometers, 3.5 miles in diameter. NASA Science plus 2, Wikipedia plus 2 energy drivers. The large CO2 dominance suggests Either the nucleus is intrinsically rich in CO2, formed beyond CO2 ice line in its parent system, or that water sublimation is being suppressed, perhaps by an insulating crust or low thermal conductivity. RxEv +2 Live. Science +2 outburst versus steady activity. Is the increased brightness a sudden surge or gradual increase? Pre-discovery observations, ZTF, etc., suggest the comet has been active as far out as the 6.5 AU, with a dust production rate rising over time. But strong bursts haven't been clearly observed until now. Our sieve is something hidden in observations. Some speculation arises because of gaps or less frequent image releases from large telescopes. But the data that is published, JWST, HST, SphereX, etc., is consistent with cometary behavior, albeit extreme. No credible evidence yet has been published that suggests anything artificial or designed. Part 4. Why the silence? The claim that every major telescope is silent since August is not quite accurate. There are publications and data. JWST published CO2-dominated coma observations in late August. SphereX released data in mid-August. Ground-based telescopes and Hubble have continued monitoring. European Space Agency +4 SphereX +4. However, it is true that some expected new imaging or dramatic updates haven't materialized in the media or public releases. Possible reasons. Many observations take time to analyze and peer review, especially when spectral data or imaging involves faint, distant objects. The comet's orbit makes it harder to observe at certain times, e.g. solar elongation, when it's too close to the Sun from Earth's view. Some telescopes may be scheduling constraints or prioritizing other missions, so the silence might be more about practical delays than a cover-up or mystery, at least based on what is known. Part 5. Predictions and what to watch. For what should we be paying attention to in the coming weeks and months? Here's what astronomers are eager to see. Perihelion, closest approach to Sun 3I Atlas, is expected to reach perihelion around October 29 to 30, 2025, at a distance of about 136 to 1.40 AU from the Sun. Wikipedia, +2 Live Science, +2 brightness curve behavior. Will the comet continue to brighten faster than models allow? Will there be outbursts, fragmentation, or sudden changes in appearance? Spectra evolution as it warms. We expect more water vapor, maybe other volatile molecules, changes in dust grain sizes, etc. Whether CO2 continues to dominate or water catch up will tell us about the internal structure and thermal dynamics of the nucleus. Imaging of dust tail and coma. Will the coma expand even more? Will tail structures develop, ion tail, dust tail? Will the tail or coma show signs of complex plasma structures, filaments, as solar wind interacts with the comet's coma? Polarimetry and light scattering. Further observations at different phase angles can clarify how light is being scattered through dust and ice. That helps understand composition and grain size distribution. Conclusion. Natural wonder, not sci-fi. Mystery based on what we currently know. II Atlas is unusual but still consistent with cometary physics. Its high CO2 content, strong early activity, and steep brightening rate are extreme cases, not total aberrations. There is no compelling scientific evidence that this is anything other than a natural interstellar comet object. The more exotic ideas, design, artificial origin, remain speculative, unsupported so far. The upcoming observations, especially around perihelion, will likely yield even more surprising data. We may be in a position to rethink some of our models about how comets form, how volatiles are preserved in interstellar space, and how activity proceeds in very CO2-rich or cold-formed bodies. Molecules in the nucleus break down to produce diatomic carbon, C2, which is what normally gives comets their characteristic green glow. The intensity of that fluorescence depends on how much solar radiation the comet receives and how many carbon-bearing molecules are present in its composition. But 3I Atlas's green glow is puzzling because it doesn't quite follow that standard pattern. Early spectroscopic studies of 3I Atlas show it is unusually rich in carbon dioxide, CO2. yet it has limited signs of the classic carbon chemistry, especially C2, that typically causes green fluorescence, R-Kiv+2 Science Alert +2. With that combination, the green color ought either to be much weaker or to appear later. Instead, observers have seen the green glow earlier and stronger than expected, given both the comet's distance from the Sun and its chemical makeup. Space +2 Science Alert +2. Scientists find that discrepancy surprising, and they are still studying exactly what is going on. Science Alert +2 Space +2 to understand why this matters. Consider the delicate balance of chemistry in a comet's coma. Solar radiation heats the nucleus, causing different volatile materials to sublimate, turn from solid to gas, at different temperatures and at different distances from the Sun. Water ice, H2O, requires more heating to sublimate. CO2 turns to gas much further away, i.e., at lower solar heating. Meanwhile, complex carbon molecules, organics, can decompose into simpler molecules as the heating increases. The green glow arises when molecules like C2 are broken down and excited by solar UV photons. Normally, this happens at a certain distance from the Sun, once enough solar energy is available and certain molecules are present. But with 3I Atlas, the glow seems to begin earlier or with greater intensity than our models predict. It's as if there is carbon chemistry at work we haven't fully seen before, or the solar heating is affecting its volatile materials in unexpected ways. One possible explanation is that as the comet is heated, fresh volatile material, previously buried beneath a surface crust, is being exposed, suddenly releasing those carbon molecules, or precursors, that cause green fluorescence. Another possibility is that molecules other than C2, or in addition to it, are contributing to the glow, perhaps cyanogen, CN, or other carbon-bearing species. Indeed, CN has been detected in the coma of 3I Atlas. Archive +2 space +2. It's also possible that the chemistry of the coma is shifting as the object gets closer to the Sun. Stable molecules at larger distances begin to break apart. New chemical species form. The relative abundance of carbon molecules that fluoresce may increase rapidly. CO2-dominated coma. The James Webb Space Telescope, JWST, observed 3I Atlas when it was about 3.32 AU from the Sun and found a coma dominated by carbon dioxide with a CO2-RH2O mixing ratio of about 8.0 plus 1.0. There are also detections of H2O, CO, OCS, water ice, and dust in the coma. Archive. This is among the highest CO2-H2O ratios ever recorded in a comet. Archive polarimetry and negative polarization. Branch observations from July through August 2025 using instruments like 4RS2 at VLT, ALPHOS, NOT, and 4ERO2 Rajan show that 3I Atlas has an unusually deep and narrow negative polarization branch, reaching a minimum of about 7% at a phase angle near 7 degrees, and an inversion angle of about 17 degrees. That is a combination not previously seen among comets and asteroids, including other interstellar comets like 2I Borisov, Dyaarg-Jev Growing Tail, Coma Expansion Gemini South Telescope. Captured images on August 27, 2025, showing a growing tail and more pronounced coma from 3I Atlas. Space +1 also, Atlas photometry shows changes in brightness and color consistent with increasing activity and coma changes. For example, a slope change in the brightness versus heliocentric distance, evolving color from red to more neutral, and the appearance of an anti-solar tail, R-Civ anti-tail, sun-facing plume geometry. There is evidence of a sun-facing plume in the coma, dust gas emitted preferentially from the sunlit side, observed in July-August 2025. Later, a more classical anti-solar tail becomes more visible. This fits with changing viewing geometry and increasing coma or dust material as the comet nears the Sun. Wikipedia +2 no R-Lab DDU +2 size estimate of nucleus Hubble observations from July 21, 2025, give an upper limit on the nucleus diameter as about 6 kilometers, 3.5 miles, though it might be significantly smaller. NASA science unverified or speculative claims, where caution is needed. Green glow much earlier, stronger than expected in terms of timing and intensity is plausible, but not fully confirmed in scientific literature. While there are color and spectral observations, many reports are media summaries, and exact quantitative timing, relative to model predictions, is still under study. Digital image enhancements. Yes, this is real. Photographs and processed images may exaggerate color or contrast. Scientists use spectral measurements, not just images, to confirm phenomena like diatomic carbon emissions. But it's true that images alone can mislead. Specific molecules besides C2, e.g. cyanogen, CN, appear in some claims, but many are not confirmed or are preliminary. Some emission features are detected, but the dominance of one molecule over another in causing green glow is still under investigation. Rotation, variation in brightness over hours or days. Some observations note changes in coma brightness or shape, which could be due to rotation or changing dust gas emission. But determining nucleus rotation from these requires careful modeling. It's not yet a firmly established measurement for 3I Atlas as of latest papers. Corrections, clarifications. Based on evidence, the polarization anomaly is real. Deep negative polarization at small phase angles. That is uncommon, but it doesn't directly mean the comet is alien or artificially made. It just signifies unusual mix of dust, ice, and scattering behavior. Eerie, the anti-tail and sun-facing plume, are real phenomena, but many earlier spikes toward the sun are due to geometry, how the dust sheet is oriented, how Earth sees it, rather than violations of physical laws. There's also a new paper specifically about the physics of cometary anti-tails, as observed in 3I Atlas, which offers a model, elongated coma, ice grains, whose sublimation depends on illumination angle, etc. Archive, the brightness, color evolution. Atlas photometry shows that color changed from red toward more neutral, coincident with the appearance of a prominent anti-solar tail. Also a slope break in magnitude versus heliocentric distance, that is, how brightness changes as comet gets closer to sun. Extended CO2 coma Spherex observed a bright CO2 coma surrounding 3I Atlas that extends to at least 348,000 kilometers. The observation was between August 8-12, 2025, when the comet was far from the sun, 470 million kilometers away. This confirms the existence of a very large CO2-rich gas envelope. Spheric's dominance of CO2 over H2O in coma gases JWST spectroscopy at about 3.32 AU from the sun found a CO2 dominated coma with a CO2-H2O mixing ratio of about 8 plus 1.0, among the highest ever measured in a comet. H2O, CO, OCS, water ice, and dust are present, but CO2 is very dominant. RXIV size constraints of the nucleus Hubble observations, July 21, 2025, give an upper limit for the diameter of the nucleus of about 6 kilometers, though it could be significantly smaller. NASA Science +2 ESAHubble.org +2. Another study, Hubble High-Resolution Imaging, limits the radius to 2.8 kilometers given assumptions about albedo and coma contribution, R-Kevi polarization anomaly. Polarimetric observations from instruments like FORCE 2, VLT, NOT, Rosen show a deep and narrow negative polarization branch in the coma, reaching a minimum of about 2.7% at a phase angle near 7 degrees and an inversion angle around 17 degrees. This behavior is unusual compared with both solar system comets and the other interstellar object observed, 2I Borisov, R-Civ onset of CN emission and carbon chain depletion A. Spectroscopic campaign AUG 8 to 17, when the comet was between about 3.2 to 2.9 AU, observed weak CN cyanide emissions starting to appear. Earlier nights had no CN, then it increased. Also, the ratio of C2 to CN is very low, which places 3I Atlas among the more carbon chain-depleted comets known, IR-Civ mass loss and dust activity. Hubble images show dust being emitted, especially from the sun-facing side, and a weak tail due to radiation pressure. Mass loss in dust is estimated from 6 to 60 kilovasas depending on particle size assumptions. AR-Civ, speculative or unconfirmed claims. Areas requiring caution. Green glow early and stronger versus exact timing, while spectral data confirms classic emissions, e.g. CN, some carbon species, and CO2 dominance. Claims about when exactly the green glow began relative to expectations are less well quantified. The presence of carbon chain depletion, C2 weak relative to CN, suggests that the green might be weaker or delayed, which complicates claims about glowing green earlier than expected. R-Civ intensity exaggerated by image enhancement. This is valid caution. Photographs can be processed to increase contrast, color saturation, making green more vivid than what naked eye or unprocessed observing might show. Scientific confirmation requires spectral lines, not just images. Many of the observed green signature claims come alongside spectroscopic confirmation, e.g., CN, carbon species. But one must be careful not to overinterpret color from images alone, speed and orbital path, close pass, and patterns of coincidence. Some claims in your text, e.g. that 3I Atlas will pass extremely close to Mars at a very small distance, or that there is a pattern of comets and asteroids timed as a swarm, are not strongly supported by published data. The literature confirms the object is interstellar with a retrograde, hyperbolic orbit, inclination close to 5 degrees relative to ecliptic. But many of the more dramatic swarm of comets and asteroids claims are more about perception than clearly connected orbital. Dynamics, Wikipedia +2. The Guardian +2 artificial. Non-natural explanations. Credible peer-reviewed journal article strongly supports a technological or artificial origin. Most publications are consistent with 3I Atlas being a natural comet, albeit with unusual chemical composition and behavior. Some commentary or speculation, blog posts, op-eds, may explore exotic alternatives. But that is still speculative. Live Science +2 R-Civ +2. How this changes adds to your script. Claims based on the evidence. You can reliably claim that 3I Atlas has a CO2-rich coma extending hundreds of thousands of kilometers, that its nucleus is no more than 5.6 kilometers in diameter, and likely smaller, and that it shows strong negative polarization features not seen before in many comets. You should be more cautious about claims of exact early green glow timing, or that visuals are defying all solar physics. While behavior is unusual, many aspects are being explained by standard comet physics, volatile sublimation, dust emission, geometry, etc. The polarization data is indeed a strong oddity and supports parts of your text about the unusual reflectance, scattering behavior. Extreme Negative Polarization Branch, NPB-A. Recent paper, Extreme Negative Polarization of New Interstellar Comet 3I Atlas, reports that 3I Atlas exhibits a deep and narrow negative polarization branch, reaching a minimum of about 2.7% at a phase angle around 7 degrees, with an inversion angle of about 17. These values and this combination are unprecedented for comets or asteroids, including previous interstellar comets. R-Civ upper limit on nucleus size, brightness constraints, in a preprint by A.V. Loeb and others on AR-Civ. It's calculated that the brightness of 3I Atlas suggests an upper limit for its nucleus, radius, if it's asteroid-like albedo, of about 10 kilometers, but to avoid problems with mass density of interstellar objects. The paper suggests either a smaller core, 0.6 kilometers, or that the type of object is rare. Web.zfa, harvard.edu precovery. Photometry and lack of clear rotation period using test precovery images before the official discovery. The object was observed to have weak cometary activity even at large distances from the Sun, and no statistically significant rotation period was detected from those early light curve, deep stack images. Archive. Speculative, unconfirmed, or partially supported claims, artificial or non-natural origin. There is no published scientific evidence confirming that 3I Atlas is artificial. Some commentary or essay writers, blogs, speculative articles suggest this possibility. But in peer-reviewed literature and in observational data, the explanation is being treated as a natural object with unusual properties. Trajectories or active control or non-gravitational maneuvers, claims about course corrections. Maneuvering or propulsion systems have not been substantiated. Its orbit is consistent with a hyperbolic trajectory from interstellar space, but there's no observed non-gravitational acceleration strong enough to suggest propulsion. Presence of exotic materials, e.g. engineered surfaces, metamaterials, etc. Features like extreme polarization might suggest unusual dust grain properties, unusual composition or irradiation effects, but not necessarily artificial materials. The data do not require artificial explanations. There are multiple natural mechanisms still being explored, specific chemical abundances beyond confirmed ones, some speculative claims in popular articles about extremely exotic composition, e.g. high proportions of industrial metals, unusual engineered alloys, are not confirmed in peer-reviewed astronomical observations. How evidence affects. Claims in your script based on the real results. You can confidently include the part about the unusual polarization, 2.7% at them 7 degree. Inversion angle Batzen 17 as a confirmed oddity. You should avoid or frame carefully claims about artificial origin, propulsion, or controlled behavior, unless you mark them explicitly as speculation. Claims about nucleus size should mention the uncertainty, upper limits, possible smaller core. Claims about no rotation detected are supported by test data, no statistically strong signal yet. Origin in another star system. Ejection mechanisms. We do have credible models and observations that 3I Atlas was formed in another star system and was ejected. For example, the JWST observations show a CO2-dominated coma and suggest that the object might have formed beyond the CO2 ice line in its parent protoplanetary disk, ARC-7. Paper from a different star, 3I Atlas, in the context of the Otautahi-Oxford Interstellar Object Population Model, Hopkins et al., predicts the properties of interstellar objects, and finds that 3I Atlas's velocity and trajectory are consistent with expectations for objects ejected from star systems in the galactic disk, ARC-7. Unusual chemical composition that implies cold formation because it is rich in CO2 with relatively low water vapor when observed far from the Sun. It suggests that 3I Atlas formed in extremely cold conditions, which fits with being from outer parts of a star system or other systems' cold reservoir. This is a valid clue for later possibilities like debris from outer regions rather than something warm and processed, ARC-7. Speculative, no strong evidence yet. I found no published scientific evidence confirming that 3I Atlas is one fragment of a broader debris field from a cosmic catastrophe. There are no peer-reviewed observations showing other objects on similar hyperbolic trajectories coming from the same source, or strong clustering in origin or matching chemical signatures. There is speculation, e.g. by Avi Loeb and others, about artificial origins, or unusual trajectories, too aligned with ecliptic plane, unusual timing, but these remain controversial and not accepted by the majority of scientists. Explorers Web+2 Live Science. Although some swarm or multiple interstellar objects talk appears in popular media, the scientific papers view 3I Atlas alone as an interstellar object, third known, and don't link it to a confirmed debris field of sibling objects. For example, the population models Hopkins et al. Say 3I Atlas is unlikely to share origin with the previous two interstellar objects. Archive. How you could revise your script section, debris field hypothesis, to reflect what is known versus speculation. Here's a suggested rewrite, with markers for what's established science and what is hypothetical, speculative. You can use this version or parts of it in your script. Part 7. The debris field hypothesis, science and speculation. Perhaps 3I Atlas isn't alone. Some scientists and thinkers have asked, what if this comet is one fragment of a massive debris field scattered across interstellar space by an ancient disaster? It's a dramatic hypothesis, but we should distinguish what evidence supports it and what remains conjecture. What we do know, scientific foundations, I Atlas is interstellar. Its path is hyperbolic, meaning it came from outside our solar system. NASA science, 2 plus 2, its chemical composition is unusual. JWST finds a coma rich in carbon dioxide, CO2, plus detections of water vapor, CO, dust, etc. The CO2-H2O ratio is very high, among the highest ever measured in a comet at its distance from the Sun. Archive population models, like the Otautahi-Oxford ISO model, indicate that objects like 3I Atlas may have been ejected from their home systems by gravitational encounters and are predicted to drift through the Milky Way, so it's plausible for multiple such objects to exist. But that doesn't automatically mean they are fragments from a single event. Archive, what is speculative? There is no confirmed evidence of other objects known to share origin with 3I Atlas, i.e., matching trajectory, chemical signature, or temporal coincidence, to form a debris cloud or field. The idea that 3I Atlas is a fragment from a cosmic catastrophe, planetary breakup, supernova, etc. is not ruled out, but there's no observational proof such as similar interstellar objects discovered that trace back to the same source physical fragments in space with consistent composition or path-detailed modeling that shows a plausible source event, e.g., a star whose gravitational field could eject many fragments on hyperbolic orbits. Any suggestion of artificial origin or technology is even more speculative. As of now, there is no peer-reviewed data confirming non-natural phenomena. Balanced speculative phrasing you could include. You might say something like, one intriguing possibility is that 3I Atlas is not unique, but one piece of a much larger interstellar debris field. Perhaps long ago, in a distant star system, a catastrophic event, planetary collision, tidal breakup, or gravitational disruption, ejected many icy bodies into interstellar space. Over billions of years, one of these bodies drifted into our solar neighborhood, becoming the object we now call 3I Atlas. The compositional evidence, like its high CO2 content, supports formation in cold outer regions of a system, which might align with ejected debris origin. Nonetheless, this remains speculative. Scientists have not yet identified sibling objects or a matching source event. So while the debris field hypothesis stimulates powerful imagination, we should treat it as an interesting possibility rather than established fact. CO2-dominated coma JWST observations show that 3I Atlas has a coma dominated by carbon dioxide with a CO2-H2O mixing ratio of about 8.0 plus 1.0 when it was number 332 AU from the Sun. There's also detection of H2O, CO, OCS, dust, etc. Archive water, OH emission detected. The Swift Observatory detected OH emission, which is a sign of water vapor activity at about 3.51 AU. The water production rate was estimated around 135 plus 0 Q 7 10271 35 plus 0.27 x 227 molecules per second, or 40 kgs. Archive population and origin models. The Otautahi-Oxford Interstellar Object Population Model predicts that objects like 3I Atlas are plausible, with velocities, radiant incoming direction, chemistry, etc., in the expected range for interstellar planetesimals. It also says 3I Atlas likely does not share origin with the two previous known interstellar objects, Oumuamua, 2I Borisov, Darkakshiv, speculative, or still unproven artificial, Yar technological artifact hypothesis AV Loeb. And others have published or opined papers that explore the possibility that 3I Atlas might be artificial or technological in origin. For example, a preprint titled, "Is the Interstellar Object 3I Atlas Alien Technology?" investigates this as a thought experiment. Web.cfa.harvard. Adieu. But no peer-reviewed evidence so far confirms any features that mandate an artificial explanation. NASA and other experts have publicly responded that all currently observable behaviors, coma, outgassing, tail, etc., are consistent with a natural comet. The Guardian +2 IFL Science +2 debris field, multiple interstellar fragments with common origin. There is no established evidence yet showing that 3I Atlas is part of a larger debris field, or that multiple interstellar objects are known to share a common source. Models show it's unlikely 3I Atlas shares origin with previous interstellar objects. Arshiv Scout, Saksh. Messenger probe hypothesis. This is even more speculative. It's in the realm of philosophical, theoretical speculation rather than observational astronomy at this stage. Loeb and some collaborators have explored this notion in published essays and preprints, but with strong caveats about the speculative nature. Medium +2 alweb.cfa.harvard.edu+2. Furthermore, if such probes exist, their creators would presumably have technology far beyond our current capabilities. A civilization capable of launching an object like 3I Atlas across interstellar space would have mastered materials science, energy storage, and autonomous navigation on scales that dwarf anything humanity has yet imagined. But this cuts both ways. On one hand, the very existence of such a civilization would make it plausible that they could disguise a reconnaissance probe as a comet. On the other, it raises the question, why would a culture with technology so advanced need to hide at all? If their capabilities exceed ours by thousands or millions of years, secrecy might be unnecessary, or conversely, it might be considered essential to avoid cultural contamination until a specific threshold of development is reached. This is where the scout theory enters the realm of philosophy as much as science. Ronald Bracewell argued in 1960 that messenger probes would be a logical alternative to radio communication for advanced civilizations, allowing direct study of emerging technological species. Others, like John von Neumann, speculated about self-replicating machines that could spread across the galaxy, quietly observing and reporting back. 3I Atlas, if artificial, would fit this logic. A disguised probe conducting silent surveillance before moving on, its true purpose concealed within natural phenomena. Yet the absence of clear artificial signatures remains decisive. No radio transmissions, no anomalous thrust beyond what can be explained by sublimating gases, no sudden course corrections that betray hidden propulsion systems. Everything we see so far, however odd, can be stretched to fit within the boundaries of natural cometary behavior. For now, the Scout hypothesis remains an intriguing thought experiment, a mirror in which we glimpse both our hopes and our fears about first contact. If 3I Atlas is nothing more than an unusually bright interstellar comet, it still expands our understanding of the cosmos. But if against the odds it is a disguised visitor, then history may remember 2025 as the year humanity was first observed not by distant radio telescopes, but by eyes far closer than we ever expected. Is 3I Atlas alien technology? A paper by Adam Hibbard, Adam Crowell, and Avi Loeb titled, "Is the Interstellar Object 3I Atlas Alien Technology?" explores the possibility that 3I Atlas could be technological in origin. They analyze its unusual astrodynamics, approach paths, and orbital plane tilt among other anomalies. However, that paper explicitly frames itself largely as a pedagogical exercise or thought experiment, not a definitive claim. Arxiv +1 JWST. Detection of a CO2-dominated coma and water, other volatiles, JWST, James Webb Space Telescope, has confirmed that 3I Atlas has a gas coma dominated by CO2 at 3.32 AU from the Sun, with a CO2-H2O ratio of about 8.0 plus 1.0. Other species, H2O, CO, OCS, water ice and dust are also present. Archive Swift Observatory observations found water activity, OH emission, at 3.51 AU, producing 40 kilojoules water vapor under certain assumptions. This indicates significant distant activity. Archive spectroscopy, showing water ice and dust, reddish slope in optical spectroscopic observations, Gemini S, IRTF, show that the coma contains large ice grains, and there is a reddened optical slope, which is typical of many comets. Dust extinction, Arxivo Tawatahai, Oxford. Interstellar Object Population Model A study places I Atlas in context with predictions for interstellar small bodies, ISOs, showing that its velocity, radiant, and properties are consistent with what models expect for objects ejected from distant star systems. Archive NASA's Stance NASA. Scientists have publicly stated that 3I Atlas is behaving like a comet and is consistent with natural processes. The alien tech hypothesis is viewed as speculative and not supported by concrete evidence. The Guardian +2 Live Science +2. What remains speculative or not confirmed probe, artificial origin, so far? No data definitively indicates artificial origin. The unusual properties, orbit brightness, composition are interesting. But there's no confirmed manipulative behavior, maneuvers, radio signals, etc., or anything that unambiguously points to technology, IFL Science +2. The Guardian Blue controlled brightness variation for signaling or communication. There's no published observational evidence that the brightness changes are being controlled or used as communication. Changes are more likely due to natural phenomena, volatiles, dust emission, solar heating. Use of CO2 chemistry as deliberate camouflage, propellant. While CO2 is confirmed to be dominant in the coma, there is no evidence that it is being used as a deliberate propellant or that any artificial system is hiding behind the natural outgassing anti-tail, geometry as artificial orientation or solar panel. Alignment observations do show features such as anti-solar tail, sunward plumes, etc., but geometry and viewing angle explain these naturally. So far, no evidence of orientation for power efficiency, etc. are demonstrated in study cluster. Of unusual objects as multiple probes, no confirmed sibling interstellar. Objects or group of objects sharing trajectory, origin with 3I Atlas has been identified. Motivation. Timing arguments. Why now? Why this moment? These are in the realm of speculative why rather than empirical what. They are interesting narrative framing, but not established science. CO2-dominated coma observations with JWST show that at Mar 332 AU from the Sun, 3I Atlas's coma is dominated by carbon dioxide with a CO2-H2O mixing ratio 8.0 plus 1.0. Minor amounts of H2O, CO, OCS, dust, and water ice are also present. Archive, water ice in the coma and spectral behavior. Spectroscopic work, Gemini S and IRTF specs, has detected strong water ice absorption signatures and a reddened optical slope, followed by flattening in the near IR. The coma shows a mix of icy grains and dust, roughly modeled as 30% water ice in some fits Archive Extreme. Negative polarization properties from polarimetric observations, VLT, not, Rosen, etc. 3I Atlas shows a deep and narrow negative polarization branch, minimum 2.7% at phase angle, check 7 Vader, with inversion angle around 17 dig. This combination is unprecedented for comets, asteroids including other interstellar comets like 2I Borisov.R Civ extended CO2. Coma via Spirex observations also show a very extended CO2 coma and strong water ice absorption. The measured CO2 production is large, The water and CO emissions are lower by comparison at that distance. Arcs of consensus from many scientists that natural explanations fit. While some researchers, e.g. Loeb, Hibbard Crowell, have speculated about artificial origins, the broader scientific community, including NASA, strongly state that the current observations are consistent with 3I Atlas being a natural interstellar comet. None of the data so far requires invoking artificial or engineered origin. The Guardian +1, to align with scientific consensus and avoid overstating, here are some suggestions. Phrase hypotheses about artificial origin more clearly as speculation. Some researchers have posed the possibility this is a thought experiment for timing, brightness, or orientation claims. Reference specific observations, polarization measurements, spectral signatures, coma composition, rather than attributing them to hypotheses unless there is evidence. For statements about motive, technology, or behavior of an alien probe, mark them clearly as imaginative or speculative. Where references dispute certain claims, e.g. NASA's statement that the object behaves naturally, include that as counterbalance. The Guardian +1 SphereX JWST TESS spectroscopy observations, Augie mid-September data. The SphereX mission published in mid-August 2025, results showing a strong water ice absorption feature and an extended CO2 gas coma in 3I Atlas Darchiv. The JWST detected a CO2-dominated coma with enhanced sunward outgassing. Water, CO, OCS, dust, etc. at 332 AU inbound. The CO2H2O mixing ratio 8.0 plus 1.0 ARCIV pre-discovery observations from TESS, May-June 2025, show that 3I Atlas may have been active even at 6.4 AU, and set constraints on its brightness and absolute magnitude. Archive studies on observability, conjunction periods. A recent paper, 3I Atlas, C 2025 N1, Direct Spacecraft Exploration, notes that when 3I Atlas is near perihelion, it will be on the far side of the Sun from Earth, with solar elongation of BAP 8 degrees. This substantially limits Earth-based and near-Earth telescope visibility because the Sun's glare and geometry become problematic. Archive also. Planetary.org reports that 3I Atlas will be observable until end of August, early September-ish. Then it moves into a period of solar conjunction, meaning it becomes hard or impossible to observe from Earth because it's too close to the Sun in the sky. The Planetary Society. New observations of tail and coma growth Gemini South. Telescope recently published images in September, showing a more evident tail and growing coma structure. These are available in the press and news reporting. The Debrief +1 also. Earth sky and COBS data show that brightness in mid-September is rising faster than many models predicted. Earth sky official responses. NASA has responded to claims that 3I Atlas might be alien or artificial. Tom Statler, NASA's lead scientist for solar system small bodies, is quoted saying that despite some unusual features, it behaves like a comet, and that current evidence still overwhelmingly supports a natural origin. IFL Science +1. What the data doesn't support, or where uncertainties remain. I did not find credible scientific evidence confirming that no high-resolution images of 3I Atlas were taken in September. What I found instead is that visibility becomes more difficult due to solar elongation in conjunction, which naturally limits observations. Mysterious silence or information vacuum seems more media framing. Scientific publications are continuing, but sometimes there are delays in public release, as is common with spectroscopy, data calibration. Also, some claims about major space telescopes going silent since August are not fully accurate. JWST, SphereX, TESS, etc. have data around August. The limitation comes heavily in September as the object moves into solar conjunction. Here are suggestions to align with what is verified, reducing risk of overstatement. State that observability becomes challenging in early to mid September due to solar conjunction. low solar elongation rather than implying deliberate censorship or total silence. Instead of saying no high-resolution images have been released in September, you might say publicly released. High-resolution imagery seems sparse or delayed in September, possibly because of observational constraints like solar conjunction, instrument scheduling, and data processing. Keep in mind that amateur images are often more frequent simply because many more observers can respond. But high-precision, high-resolution spectroscopy, imaging from major telescopes often have delays or are constrained by geometry. Include that official scientists, NASA, etc., affirm behavior consistent with comets, despite unusual features. That balances speculation. Part 12. The conjunction. Blackout, the observational blackout surrounding 3I Atlas, is inevitable rather than suspicious. On October 21st, the new moon coincides with the comet's minimum solar elongation, placing it dangerously close to the sun's apparent position in Earth's sky. At this point, 3I Atlas will vanish into the sun's glare, becoming invisible to ground-based telescopes and unsafe for direct observation by space observatories. Operational teams routinely suspend observations whenever targets approach low solar elongation. The risk to billion-dollar instruments from scattered sunlight and thermal stress is simply too high. Depending on wavelength and instrument design, most telescopes enforce safety margins of 15 to 30 degrees away from the sun's position. These limits are not arbitrary bureaucracy. They are essential safeguards for some of humanity's most sensitive and valuable machines. Even if instruments could safely point near the sun, the scientific value would collapse. The signal-to-noise ratio plummets as faint cometary emissions are drowned out by solar background. Attempting to capture useful data is like trying to photograph a candle flame while staring into a floodlight. From a conspiracy perspective, however, the timing looks almost too convenient. If a government agency or an international consortium wanted to obscure 3I Atlas's most revealing behavior, they could hardly wish for better cover than superior conjunction. The comet slips from view precisely when it should be at its most active and spectacular. Perihelion on October 29th, normally the moment of peak brightness, coma density, and tail development, will occur almost entirely during this natural blackout. By the time the comet emerges in late November, its most dramatic activity will be over. Yet conjunction is not a complete information vacuum. Several spacecraft throughout the solar system possess vantage points unaffected by Earth's geometry. The Solar and Heliospheric Observatory, SOHO, routinely images the solar region and could capture 3I Atlas during parts of its passage. Stereo's twin spacecraft, positioned ahead and behind Earth's orbit, provide stereoscopic views of the inner heliosphere and may track the comet from safer angles. Solar Orbiter, operated by the European Space Agency, follows an inclined orbit that carries it well out of the ecliptic plane, offering perspectives invisible from Earth. Meanwhile, Mars orbiters are preparing opportunistic observations during 3I Atlas's October 3rd flyby. Instruments such as the High-Resolution Imaging Science Experiment, HiRISE, on Mars Reconnaissance Orbiter, the CASIS camera aboard ExoMars Trace Gas Orbiter, and the stereo imager on Mars Express are capable of capturing extraordinary detail. These Mars-based campaigns represent humanity's last high-quality imaging opportunities before conjunction hides the comet from Earth. If anything unusual appears in this data, whether nuclear structure, unexpected coma chemistry, or anomalous tail dynamics, results should enter scientific archives and public communications within weeks. Mars flyby imagery will therefore be a crucial benchmark before the blackout. Adding complexity, the conjunction coincides with rising solar activity. As the sun approaches solar maximum, coronal mass ejections and intensified solar winds are expected. These conditions often rip away ion tails or trigger dramatic cometary fluctuations. Such events could obscure genuine anomalies or conversely be misinterpreted as artificial interventions. If 3I Atlas did carry engineered systems, the heightened solar background would provide natural camouflage for energy emissions or subtle course adjustments. The timeline of its reappearance will be critical. Guides predict visibility in the pre-dawn skies of both hemispheres beginning in late November. At that moment, the comet's condition will speak volumes. A re-emergence with dramatically altered brightness, fragmented structure, or non-natural tail geometry would bolster exotic explanations. Conversely, a return to predictable post-perihelion fading and conventional dust behavior would strengthen the natural hypothesis. The Earth flyby on December 19th, still a safe 1.8 AU away, will offer the best opportunity for fresh, post-conjunction scrutiny. By then, amateur and professional astronomers worldwide will be mobilized in coordinated campaigns, ensuring a flood of images and spectra. This global grassroots network ensures that even if professional institutions restrict data, thousands of independent observers will record what happens. The conjunction, then, is more than an observational challenge. It is also a test of transparency. How governments, agencies, and international organizations manage this blackout will reveal their priorities. If 3I Atlas is nothing more than an unusual but natural comet, data will flow freely once it reappears. If it is something else, something harder to classify, the blackout provides the perfect window for classified study, shielded from public scrutiny. Precedent exists. Sensitive space data has often remained locked away for years under the banner of national security. In this light, the disappearance of 3I Atlas into the sun's glare is not just an astronomical event. It is a moment of truth about how we, as a civilization, handle the unknown. Part 13. Don't Look Up. Transition from scientific discovery to national security concern could easily occur if 3I Atlas displayed characteristics that demanded government attention. From a more optimistic perspective, the conjunction blackout might simply represent unfortunate timing that deprives the public of witnessing one of the most significant astronomical events in modern history. Its reemergence in late November could yet mark a turning point in our understanding of interstellar visitors. The superior conjunction of 3I Atlas provides the perfect stage for conspiracy theorists while offering natural explanations that satisfy skeptics. As with so many aspects of this interstellar visitor's behavior, the timing feels almost engineered to maximize ambiguity and debate, and the sense of déjà vu is striking. This moment echoes a satirical cautionary tale released just 4 years earlier. The 2021 Netflix film Don't Look Up imagined a scenario in which government officials, corporate elites, and media personalities systematically distort or suppress information about a planet-killing comet. Intended as an allegory for climate change denial and institutional dysfunction, the film has become uncomfortably relevant as parallels with 3I Atlas Mount. In the movie, astronomers discover a massive comet on a collision course with Earth, but struggle to communicate the urgency. Political leaders manipulate the threat for advantage. Tech billionaires propose profit-driven solutions that worsen. The crisis and mass media treats looming apocalypse as just another spectacle. The similarities begin with discovery. In both cases, astronomers identify an unusual object that challenges conventional models, only to see their warnings filtered through bureaucratic layers and media spin. The film's portrayal of government secrecy resonates with today's observational gap. In Don't Look Up, officials know far more than they reveal, conducting classified analyses while assuring the public that everything is under control. Important differences, however, separate fiction from reality. The movie's comet was an extinction-level threat detected mere months before impact. By contrast, 3I Atlas poses no physical danger. Its Earth flyby on December 19th will occur at 1:08 AU, safely beyond even the most pessimistic scenarios. Moreover, its orbit has been tracked for over a year, with trajectory models confirmed by independent teams worldwide. There is no possibility of collision, yet the psychological dynamics align uncomfortably well. Social media amplifies polarized interpretations. Some dismiss 3I Atlas as a routine comet, others speculate about alien probes. The same clash between sober scientific analysis and sensational narratives, so central to the film's satire, now plays out across real-world platforms. Headlines about mystery comets or asteroid near misses generate clicks while burying actual scientific nuance. The film's deeper critique, that extraordinary threats become trivialized through media saturation, applies here as well. Just as Don't Look Up showed a comet reduced to background noise amidst celebrity gossip, 3I Atlas risks becoming normalized. The excitement of discovery fades, the conjunction hides it from view, and public attention drifts elsewhere. Perhaps, the film's most prescient element was its portrayal of authority under siege. The fictional astronomers struggled to maintain credibility while competing with charismatic figures who offered more emotionally satisfying narratives. A similar tension exists now. Careful, methodical science competes with conspiracy, entertainment, and speculation that command the public imagination. But satire should not blind us to legitimate questions. Don't Look Up was designed to expose how institutions mishandle challenges that don't align with short-term political or economic incentives. The absence of high-resolution September data from space telescopes, paired with the conveniently timed solar conjunction, echoes the information management problems lampooned in the film. Finally, the film's most sobering message resonates strongly with the present. Humanity's greatest vulnerability may not be cosmic threats at all, but our inability to collectively process complex information and act beyond the narrow timelines of politics and profit. CO2-dominated coma JWST observations at more 332 astronomical units from the Sun show 3I Atlas's coma is dominated by carbon dioxide, CO2, with the presence also of water vapor, H2O, carbon monoxide, CO, carbonyl sulfide, OCS, water ice, and dust. Archive the CO2-H2O mixing ratio is approximately 8.0 plus 1.0, which is among the highest ever measured in a comet. Archive +1 extended CO2 coma and water ice absorption SphereX, August 8-12, 2025, observed a CO2 gas coma extending at least 348,000 kilometers plus strong water ice absorption features. SphereX +1 water activity at large distance. The Swift Observatory detected water emission, OH, at 351 AU, with a production rate of 1,135,27 molecules s-sec, 40 kSec, from observations on July 31st, August 1st, 2025. This is notable because water sublimation at such distances is usually inefficient. RSIV carbon chain depletion. A monitoring campaign between August 8-17, when 3I Atlas was 3.22.9 AU inbound, found the onset of CN emission, but the comet is strongly depleted in carbon chain molecules, C2, etc., relative to many solar system comets. Archive NASA's official position, NASA scientists, including Tom Statler, have stated that despite some unusual features, 3I Atlas behaves like a comet. The consensus remains that it is a natural object. The debrief +1 visibility, or orbit facts. Closest approach to the Sun, perihelion, is around OK. 2025, at Mubber 1.4 AU NASA. Science +1, it will pass no closer than 1.8 AU to Earth, which means there's no risk of impact. NASA sextreme negative polarization. The polarimetric observations of 3I Atlas show a deep and narrow negative polarization branch, with a minimum of about 2.7% at a phase angle of JWST and an inversion angle of 17 RSIV. These values are unprecedented among known comets and asteroids, including 2I Borisov. R-Shiv CO2-dominated coma, unusual gas ratios JWST infrared spectroscopy at 3.22 AU inbound, revealed a coma dominated by CO2 with other volatiles, H2O, CO, OCS, water ice, and dust. The CO2-H2O mixing ratio is 8.0 plus 1.0, which is among the highest measured for a comet and significantly above normal trends at that heliocentric distance. R+2 constraints on nucleus size and mass loss rate from Hubble high-resolution Hubble observations at their 3.8 AU pre-perihelion show dust emitted from the sun-facing side and a weak tail swept by radiation pressure. Assets.science.nasa.gov. The nucleus radius is constrained to 2.8 km, assuming a geometric albedo of 0.04. Assets.science.nasa.gov dust. Mass loss rate estimated at 6 to 60 kWs, depending on assumptions about particle size.assets.science. NASA.gov activity. Early and chemistry unusual. The early detection of activity at large distances, e.g. 3.8 AU, plus suppressed water outgassing relative to CO2 indicate that 3I Atlas is behaving differently than many solar system comets in similar positions. Archive+2 Make your script more aligned with verified science. You might adjust these parts. Instead of saying no high-res images since September, say something like publicly released high-resolution imaging appears sparse in September, possibly due to observational constraints. Frame polarization and chemical anomalies as evidence of unusual behavior, rather than definitive proof of anything artificial. These measurements challenge our models, rather than these measurements rule out natural origins. When you refer to extraordinary atmospheric expansion, note that the dust, mass loss, and coma size are large for that heliocentric distance, but not necessarily impossible under natural conditions. If you keep mentions of anti-tail geometry, acknowledge that peer literature has not yet robustly confirmed an anti-tail. Atlas has already forced scientists to reconsider long-standing assumptions about interstellar comets. Its unusual chemistry, unexpected brightness behavior, and unprecedented polarization signatures push the boundaries of current models, demonstrating how quickly anomalies can ignite speculation about exotic possibilities. The honest scientific assessment is that natural explanations, though stretched, still account for the data. Exotic volatile compositions, unfamiliar dust properties, or formation conditions, unlike those in our solar system, could plausibly explain the comet's behavior without invoking artificial origins. Yet the accumulating evidence continues to challenge comfortable expectations about what normal interstellar objects should look like. At present, 3I Atlas represents one of two extraordinary possibilities: either the most unusual natural object yet detected from beyond the solar system, or something that would demand we reconsider humanity's place in the galaxy. Every new observation carries the potential to shift that balance. As it races toward perihelion, 3I Atlas looks more alien with each passing week. Whether that appearance reflects truly otherworldly origins, or simply natural processes unfolding under conditions we've never encountered before, remains the most profound question facing astronomers today. CO2-dominated coma. With additional volatiles using JWST at 332 AU inbound, spectroscopy shows that 3I Atlas has a coma dominated by carbon dioxide, with additional signatures of H2O, CO, OCS, water ice, and dust. The CO2-H2O mixing ratio is approximately 8.0 plus 1.0, which is strongly above typical comets at that distance. Argive water. Detection. Far from the Sun, the Swift Observatory detected O emission near 3085 O ultraviolet. On July 31st, Aug 1, 2025, Wars 351 AU from the Sun, indicating water production at Bound 135 x 1027 molecules per second, to 40 cars. That's quite active for that distance. Arc-Civ extreme. Negative polarization, polarimetric observations, with VLT, not etc., show 3 Atlas has an unusually deep negative polarization branch, with a minimum around 2.7% at a phase angle of about 70 inversion angle about 17 degrees. This combination is unusual among solar system comets and previously known interstellar objects. AR Civ nucleus. Size constraints. Hubble imaging from July 21, 2025, constrained the nucleus diameter to less than 5.6 kilometers or 3.5 miles, though it could be significantly smaller. The solid nucleus remains difficult to see directly even in the best images, being hidden within a dust cocoon. NASA science early outgassing activity tests pre-recovery data indicate that the comet was active, i.e. outgassing or displaying coma, earlier, May, etc., than when many initial predictions might have expected. Also, photometry from SOAR shows some early brightness behavior, universe today +1. What requires caution is less certain, while the rate of brightening, the unusual chemical composition and polarization anomalies are confirmed. The idea that they definitively point to non-natural artificial origins is not supported by peer-reviewed literature as of yet. Most scientists still consider the natural explanations plausible and likely. Claims of huge information blackout or suppression of high-resolution images in September are not clearly supported by the published sources. Though there are reports of observation constraints, solar elongation, scheduling, etc., no reliable source confirms deliberate withholding. Some media articles exaggerate or speculatively interpret data, e.g. size, color change, diplomatic, or conspiracy angles. These are not the same as scientific findings.